This illustration deals with overload protection to protect the windings of the motor and the conductor supplying power to the motor. Now, notice in the information where the arrow is right here. Notice if we select the fuses that's in the controller, then notice based upon the 62 amp nameplate current, as instructed to use this nameplate current in 430.6A2 on page 309 of the code, then we would take the 62 amps and select an overload, which would be H1051, or you could say H1051, and that would be the size of those overloads based upon the nameplate. But however, you could install fuses, which is in the disconnect here, and they could be used to back up the overloads, or actually be sized as overload protection for the windings in conductors. But notice there's some information you have to know before you do that, and that information is sizing procedure that you see here. Now notice the service factor of 1.15 or greater. Now 1.15 means the motor under certain conditions can take a 15% overload. So you could take 1.15 times 62 amps if it was fully loaded, and that's the overload capability of the motor. But say that if you had 1.10, then it'd just be 110% of 62. And then what designing engineers and electricians have to be very careful with, if this service factor was 1.00, you can't exceed the 62 amps, period. Now, that deals with service factor. Now, a lot of times in the oil industry and other chemical industries, you'll get a motor that's 1.25. That means, see, 25% overload, but those motors are very expensive. So I'd say 98% of your motors are 1.15. It's just a rule. But the temperature rise not over 40 degrees C. That means that motor has to be installed at 3,300 feet or less above sea level to use the 125% of 62 amps if that's the load of the motor, what it pulls. And notice service factor, if you're above 3,300, it's 1% reduction of loading of 62 amps for every 330 feet above 3,300. Once you reach 1,000, it's 10%. Then you start 330, 330, 330 again till you reach 2,000. Now it's 20% reduction loading without you buy a total enclosed motor, fan cool, one that will self-cool, or compressor type motor, or something of that nature. And then notice all other motors. A lot of times we go into these refinery areas and nameplates have been damaged. You can't tell. So you have to put an air probe on it and see what it pulls and use your rules of 115% or 125. But if you don't want to do that and you want to be sure, then just use 115%. Notice that's for all other motors. Now, this information is in 430.32A1. But the temperature rise factors information and the over 40 degrees C, where you're above 3,300 feet above sea level, you have to purchase NEMA 1 motors and generators, and that information is there also. However, if you want it with illustrations and detailed information that comes out of NEMA 1 motors and generators, get you a copy of the Stallcup's generator, transformer, motor, and compressor book with illustrations. It's a choice, however you want to do that. But this information's given, and to me, that's what you need to know before you get into designing motors, protection with overloads. Now, looking at finding the motor overload protection, step 1, 430.6A2 on about page 309 of the code says use the nameplate, so we selected 62 amp. Step 2 now, 430.32A1, says if your service factor, is, say, 1.15, your temperature rise is 40 degrees C, we could use 125%. SF is for service factor, TR is for temperature rise. Your abbreviations are in the very back of the design book. And the abbreviations that we use in the illustrations are outlined there, so you know what each abbreviation means in case you're not aware of it. Well, just exactly what's that abbreviation represent. You can go to the abbreviation charts in the back of the design book, and they're listed for you. Now, we would take then the 125% times the 62 amps, and we'd come up with 77.5 amps. Now remember, this motor is 115% service factor, 40 degree temperature rise, which most all motors are that you special buy them. And if we came up with 77.5, you round it down to 70 amp fuses. 5 times 70 is the holding power, so that'd be about 350 amps. So your motor would have to start at less than 350 amps and also accelerate the load. And then if you wanted to round that up to 80 amp, then you would back up the overloads. The overloads would have a chance to function first in most all cases. Now, basically, what you're reviewing there is that, again, the fuse will hold 5 times its rating. But you're backing up your overloads, so you're giving your overloads a chance to operate. 80 amp fuses. If you took, say, 62 amps times 1.732, that's what, the fuse would see. So if you had an 80 amp fuse and you lost, say, L2, L1 and L3 was feeding that motor in a Y configuration, say, or however it's connected, then notice your 80 amps times 1.732 would, that's how long it would carry that amount of current before it opened up. So, you're going to be above the 125% with 1.732. So engineers use this kind of as a rule of thumb that they can gauge how many amps the 2 remaining fuse would pull per amp, and it's 1.732 times 80, the square root of 3. So you're going to be above that 125%, and you're going to back up those overloads. If it's 70 amps, same thing, 1.732 would be the 2 remaining fuses, so you're going to protect that motor from overload. Now, selecting the size of the time delay fuses would be 70 amp there for overload protection, 80 amp to back up the overloads. And then notice fuses, you can use a smaller size disconnect in many cases with that 125% rule, where you don't, and remember, disconnects they come in 30, they come in 100, then they jump 200, 400, 600 sizes, see? So that's why 240.6A1 has that 601 amp fuse, because you can put it in a 600 amp rated disconnect, see? So keeping that in mind then, so overloads in the controller, then the 125% rule would not apply there at all. You would just use the nameplate current to select your overloads. And that's what this figure 18-32 is illustrating. Sizing the overloads using the exact nameplate current to select the overload from a chart. Or you can use the 125% based upon service factor or temperature rise, and you can either use fuses for overload protection or to back up the overloads. And that has been an engineering concept for many, many years. And that's what our figure 18-32 again is illustrating.